Hello, my name is Austin Gabb of Team 6, and our senior project is correlating liquid loading predictions and plunger lift success. Here's a basic outline of our presentation. First, we will show you our progress report. Next, we will show you simulation methodology. Third, we will show you our industry data. And finally, we will provide you with our possible backup plan. Previously, as of October 1st, we as a group had just finished gaining a complete understanding of the information needed to begin our project. We were in the process of reaching out to our industry contact to gather the data we required. Currently, we have gathered the majority of the data from our industry contact who opted to remain confidential. Now we are analyzing and digesting the well data, and we should be able to begin generating IPR and TPRs using PipeSim.
The program we are using is PipeSim nodal analysis, which we will use to generate the relationships between IPR and TPR curves. The requirements for the simulation include well profile, production rates, and pressures, just to name a few. The assumptions we are making is that flow is multi-phase steady state, and that the data points we receive from our industry contacts are representative of the well. Just to briefly demonstrate PipeSim nodal analysis, we will take you step by step through the process. First, we need to input the casing design. Second, we must input the tubing profiles shown in blue in the picture. Next, we must input reservoir conditions such as pressure and temperature and production information, including productivity index. Additional production information includes water cut, GOR, specific gravities, and API gravities.
The last step in generating the IPR curve is inputting any completions information for the well. For our data set, which is comprised completely of horizontal wells, we must ensure precision in this step. Generating the TPR curve is done with wellbore configurations and the flow rates provided previously. We will analyze this curve where it crosses the IPR curve, as this says a lot about the production of the well. As seen here, PipeSim nodal analysis has the capability to generate multiple TPR curves per IPR relationship. This will be useful for analyzing hypothetical cases to determine optimal well configuration. Some of these hypothetical cases include, but are not limited to, differing casing and tubing sizes and different wellhead pressures.
We received a list of plunger wells from our company contact. From that list, we went through and determined successes and failures that our team established would be our criteria for determining them. From that list, we got a sample set of 48 failures and 42 notable successes that were very effective in stopping the liquid loading and in some cases increasing the production of the well. What you can see in this picture is some of the very important information we have already received from our company contact, such as pressures for the casing, wellhead, and pipeline, as well as flow rates of both water and gas. In addition to the production and pressure information, we also have received some wellbore configuration data that you have seen we will need for PipeSim. This is a zoomed in picture of what we have. The full spectrum of our data is contained in this picture. Although we do have a healthy amount of information to start our analysis, we are still waiting on some reservoir information on these wells since our contact did not have the immediate access to the reservoir data. However, we don't expect this to delay any of our deadlines. From this list of 90 wells, we further narrowed them down to 20 successes and 20 failures of the wells with the best data available to ensure the most accurate results possible for our simulations. We will begin our IPR and TPR analysis for the wells using PipeSim. Since we do not have the reservoir data yet, we will start with the TPR analysis, but then eventually move on to the IPRs and start correlating the two. If we do not find any positive correlation between where our IPRs and TPRs intersect, our backup plan is for us to start looking at other things that we believe may be causing the failures of the plungers. Some things that we may look at but are not limited to are the gas-liquid ratio, scaling of the well, sand production of the well, as well as dogleg severity in the tubings. All of these may definitely have an impact on the success of our plungers, and it may be something else that is causing our failures rather than simply the time at which it is put on. This concludes the progress that we have made so far in our project. Our advisor Paula believes that we are well on track to complete our goals, and we also believe that we will finish with our deadlines. If there are any questions, feel free to contact any of us and we'll be glad to answer them.